In this video, we are going to continue our exploration of function notation. So remember, excuse me, function notation is this idea of f of x. And f of x means all sorts of things. So we can say f of x. We know that our y is our function of x. We can also say y is dependent on x. Y is what we say is our output or our dependent variable. These are all synonyms in a way for this idea of saying f of x. Again, it's a really fancy way of just saying y. So remember, a function means that for every input, that's my independent variable, my x, I am going to get exactly one output or one y value. So when we think about this, if we think we have this function, we could call this f of x of 2x plus 7. What happens when I plug in each of these inputs? Well, when I plug in the 3, I am going to get 2 times 3 because that's the idea of I'm replacing the x with 3. So I get 6 plus 7. So f of 3, I could say f of 3 equals 13. Similarly, if we plug in a 6 for x, I'm going to get 2 times 6 plus 7, which is going to be 12 plus 7. So I could say f of 6 equals 19. And lastly, if we were to plug in 95 for x, that means again, we're replacing x with that 95. So 2 times 95 plus 7. So I could say that f of 95 equals 197. So I want you to pause the video here and I want you to try these two on your own. Hopefully this feels like a good recap or practice from yesterday. Okay, you're back. So hopefully when you did f of 6, you plugged in 6 for x, and you got 12 minus 3, which is going to get you to 9. And when you did g of negative 2, that means you're replacing that negative 2 into x. So you're getting 3 times negative 2 plus 7, which should have gotten you a value of 13. Okay, so one of the things that I want to talk about now is what if we now say g of x equals negative 8? So the fact that it's telling us g of x means that we're only going to focus on this function here. But instead, you'll notice that they have now given us the output, and we are looking for the input. So what this means is I'm going to take this negative 8 and I'm going to replace it or plug it in to that entire g of x. So I'm going to rewrite my equation as negative 8 equals negative 3x plus 7. Again, this time they've given us the output and I'm looking for my input, which is x. Now that I have this equation of negative 8 equals negative 3x plus 7, that's like riding a bike, right? Back to 7th grade, we know exactly what to do. We're going to subtract 7 from both sides. So I'll be at negative 15 equals negative 3x. I'm going to divide by negative 3 on both sides, and I will get x equals 5. So what this tells me is that when I have, whoops, dealing with g, not f, when I have g of x equals negative 8, I know that x has to equal 5. So in other words, if I think about me having this like g of x machine, right? And if I know now that if I plug in negative 5, I'm going to get out an answer of negative 8. Okay? All right, now I want you to pause the video here and try this one on your own. So f of x equals negative 13. Okay, so hopefully you realized again, they've given us our output and we are trying to find our input or find the value of x. So I'm going to take this negative 13 and I'm going to plug it in for f of x. So I'm saying 13 equals 2x minus 3. Again, you know how to solve this equation, right? I'm going to add 3 to both sides. So I get 16 equals 2x. Divide by 2, divide by 2. So I know x equals 8. So again, what this means is that if I have f of x equals 13, then that means x has to equal 8. Or if we think about this as our little function machine, right? If I have the machine of f of x, and I'm plugging in, I know now that if I plug in 8, right, because that's my input, my answer will be 13. Okay, The last thing in terms of equations and solving like this is what if we say find x if f of x equals g of x? So now our equation here has f of x and g of x. So we're actually going to use both of these functions. And because here they've been set equal to each other, I'm going to do the same thing. I'm going to take my 2x minus 3 and my negative 3x plus 7 and set them equal. So I'm going to say 2x minus 3 equals negative 3x plus 7. Again, what we've done is I've basically said here, remember this is f of x equals g of x. I've just replaced it with the actual equation that is represented in the function. Now that I have this blue equation, I'm going to solve. I'm going to bring my variables to one side, and I'm going to bring my constants to the other. So I'm going to end up with 5x equals 10. I'm going to divide by 5 on both sides, and I'm going to get a value of x equals 2. So what this tells me actually is that if I plug in 2 into both f of x and g of x, my answer will be the same. That's what this is saying. So let's try. Let's see, what is f of 2? So I'm going to plug in 2 for x. I'm going to get 4 minus 3. And so I'm saying f of 2 equals 1. I'm going to do g of 2. So I'm going to get negative 3 times 2 plus 7, which is going to be negative 6 plus 7, which means g of 2 equals 1. So what we've determined here is that if I plug this 2 into either the f function or the g function, my outputs are the same. F of x equals g of x when your input is 2. Okay, last but not least here, we are going to look at graphs. And so what I've done here is I've graphed this function of f of x. And on the left-hand side, you can see here, we are looking to find what is the output if f of negative 3. So that means that I want to find x of negative 3. So remember, this is my x-axis, this is my y-axis. So I'm going to go find f of negative 3. 1, 2, 3. Here's f of negative 3. And I'm going to plot up to where does it cross? It crosses right here. And so I want to find what is the y value, what's my output if I have an x of negative 3. And that is positive 5. Because you can see that this point right here is negative 3 comma 5. When I plug in x, I get out y. So what about f of 0? Well, I know f of 0 is right here, x of 0. So I'm going to go up and find the function right here. And that is 0 comma 2, that point. So I know my output here is going to be 2. If I plug in 0 for my function, my output will be 2. Well, what if we go the other way? So again, remember, this is your x-axis, this is your y-axis. Now you can see that they have actually given us f of x equals 4. So that's saying they've now given us the output of 4. So I'm going to go up on my y-axis 4, 1, 2, 3, 4, and I want to see where does it cross this line. And it actually crosses in 2 places. It's going to cross at negative 2 comma 4, and it's going to cross at negative 4 comma 4. So the answer here is that x equals negative 4 or x equals negative 2. Remember, it's okay for 2 inputs, 2 x values to have the same output, right? Because 2 people can have the same birthday. Again, let's think about f of negative 1 here. Now I'm going to go down negative 1, and I'm going to see where does it cross here. Again, I end up with 2 values. I have one right here and one right here. So this coordinate is going to be 1, 2, 3, 4, 5. So this is 5 comma negative 1. So I know one of my inputs could be 5 or 6, 7, 8, 9, 10. This is 10 comma negative 1. So my other value would be x equals 10. So hopefully this makes sense in terms of how to continue to use your functions as well as how to interpret function notation on the graph. Let us know if you have any questions.